Here, life always begins in silence. Nature operates as an unforgiving battlefield where every living organism enters life under the same basic pressure, which is survival. From the very first moment, life is tied to risk, and every individual must adapt to existing threats within the environment where it is born. In this world, there is no concept of absolute safety. Every living space, from open grasslands to dense forests and muddy rivers, contains its own specific dangers. When a threat appears, there is no time for hesitation, because a single moment of delay can change the outcome. Each natural environment imposes different harsh conditions that force species to respond quickly and accurately to surrounding changes. Survival pressure does not allow prolonged errors, and delayed decisions often result in energy, loss, injury, or death of the individual involved. The boundary between life and death, therefore, remains fragile and shifts with even the smallest movements in the landscape. In these critical moments, instinct becomes the final tool that every species can rely on. Instinct controls reflexes, directs behavior, and determines how an individual confronts danger at the moment it appears. Without conscious thought, the body responds according to patterns shaped and refined through millions of years of continuous evolution. Predation and avoidance occur in silence, as both predator and prey attempt to limit any signs that could reveal their position. The predator moves cautiously, using darkness, terrain, and distance to conceal its presence. At the same time, the prey continuously observes the surrounding environment, searching for the smallest changes within familiar space to detect approaching danger. In this context, every movement carries risk. A careless step, an unexpected sound, or a slight change in wind direction can completely alter the situation. Silence is not merely a static state, but a period of tension in which both sides wait for the other to make a mistake. Within this quiet space, confrontation often begins before either predator or prey clearly recognizes the presence of the other. The question is not whether the encounter will occur, but when one side will break the silence first. The outcome depends on whether that action is fast and precise enough to determine the fate of the other. The South Luangwa Savannah is shaped by the slow but heavy movement of elephant herds crossing the open grassland. Each step presses deep into the hardened ground and leaves clear marks among low grass and scattered shrubs. Trails formed by repeated movement extend across generations. And reflect the persistent presence of the largest land animal within the regional ecosystem. For African elephants, migration is not simply a response to seasonal rainfall or dry periods. These journeys are guided by collective memory accumulated over long periods. Where roots, water sources and feeding areas are remembered and passed on. Through this memory, elephant herds can reach critical resources even when environmental conditions become harsh and familiar signs of water and food are difficult to detect. The size and body mass of elephants create direct and long-term effects on the savanna landscape. As herds move, shrubs are pushed down, branches are broken, and surface soil is disturbed under the pressure of thousands of footsteps. These changes are not limited to immediate presence, but gradually reshape habitat structure and influence how other species use and occupy shared space. From these effects, African elephants are considered ecosystem engineers. By opening pathways through dense vegetation, creating open areas where sunlight reaches the ground, and maintaining exposed water zones, they increase habitat diversity. These changes create opportunities for many other plant and animal species to survive and develop in the savanna, including small grazers, birds and insects that depend on open environments. The social structure of elephant herds plays a central role in this process. Herds are typically led by a matriarch that possesses extensive experience and long-term environmental memory. The matriarch decisions, including movement direction and resting timing, directly affect resource access and overall herd safety throughout the journey. Herd cohesion is maintained through communication methods beyond audible sound. Elephants use low-frequency infrasound signals that can travel long distances through air and ground. This form of communication allows individuals to remain connected and coordinate behavior even when spread across large areas of the savanna. At South Luangwa, African elephants face increasing threats. Habitat reduction combined with human activities increases conflict and pressure on the population. In response, conservation efforts focus on maintaining migration corridors, protecting water sources, and reducing human-elephant conflict. These actions aim to ensure that the ecological role of elephants continues to be maintained within the savanna. During the day, hippopotamuses remain almost motionless in the turbid water of rivers and wetlands, where direct sunlight rarely reaches the entire body. Most of the large body stays submerged, which allows hippopotamuses to avoid intense tropical heat and maintain stable body temperature for many hours. Only the eyes, ears and nostrils rise above the water surface, which is sufficient to observe surrounding space and monitor movement within their aquatic territory. The thick skin of hippopotamuses secretes a light pink fluid, often called red sweat. That covers the skin during prolonged exposure to sunlight and water. This fluid functions as a natural protective layer that reduces solar radiation impact and limits bacterial growth. In turbid water rich in microorganisms, this protection plays an important role in long-term individual health. With large body size and weight that can exceed several tons, hippopotamuses move through water with notable stability. Despite their massive appearance, body structure allows controlled and flexible movement underwater, where buoyancy supports most body weight. Hippopotamuses can change direction quickly and maintain precise movement control in wetland environments where mud accumulation and slow currents create obstacles for other species. When night falls, hippopotamus behavior changes clearly. They leave the water to feed on land and move across riverside grasslands and low savanna areas. This process usually occurs in silence, as individuals or small groups graze continuously for several hours before returning to the river at dawn. Night feeding reduces direct exposure to threats in open environments and limits daytime competition. The jaws of hippopotamuses are among the strongest structures in the mammalian world. Large canine teeth are not used for hunting, but serve primarily in territorial disputes and status assertion. During confrontation, jaw display and exposed canines are often sufficient to establish boundaries and limit escalation into dangerous physical contact. The social structure of hippopotamuses centers around aquatic groups typically controlled by a dominant male. This male defends the water territory where females and calves remain during daylight hours. Territorial control maintains group order and reduces intrusion by other males, especially in areas with high hippopotamus density. Hippopotamus reproduction occurs primarily underwater, which matches the semi-aquatic lifestyle of the species. Calves are born in this environment and quickly learn to surface for breathing while receiving close protection from the mother and nearby individuals. Early life stages remain closely associated with water, where calves adapt to wetland conditions. Within wetland ecosystems, hippopotamuses play an important role in linking aquatic and terrestrial environments. Movement and feeding activity create pathways that influence vegetation, distribution, and nutrient flow between water and land. However, due to body size and strength, hippopotamuses are also considered one of the most dangerous animals to humans in Africa. Risk increases when nocturnal movement routes are disturbed, which raises the likelihood of unintended conflict. Nile crocodiles function as highly effective ambush predators within African freshwater ecosystems where most hunting occurs outside the awareness of prey. For many hours, crocodiles remain motionless beneath the water surface, with only the eyes and nostrils exposed above the calm river and wetland surface. This stillness reduces the visible distinction between safety and danger because prey often fails to detect the threat until contact occurs. The body structure of crocodiles is optimized for prolonged ambush behavior. Thick skin with hardened scales protects the body from impact and resistance, while the elongated body and developed musculature allow energy storage during immobility. The powerful tail serves a central role by generating sudden propulsion from underwater and enabling short-distance acceleration at the moment of attack. The bite force of the Nile crocodile ranks among the strongest in the animal world and reflects its position at the top of the food chain. When the jaws close, the pressure produced is sufficient to restrain and immobilize prey almost immediately and reduce the ability to resist. This force is not applied continuously, but is reserved for the decisive moment when surprise reaches its highest level. Crocodile hunting strategy does not rely on extended pursuit or high energy expenditure. Instead, crocodiles wait until prey approaches close to the water edge, where short distance and surprise strongly favour the ambush predator. A brief, precise and forceful attack is often sufficient to end the encounter within seconds. Nile crocodiles are opportunistic feeders with diets that change according to body size and environmental conditions. Juveniles primarily hunt fish and small aquatic organisms, while adults can attack water, birds and large mammals when opportunity allows. This ability to exploit diverse food sources enables crocodiles to adapt to seasonal changes within river systems. During the reproductive cycle, crocodiles demonstrate significant offspring care. Females protect nesting sites from threats, assist hatchlings after emergence, and transport young individuals to water. During early life stages, juvenile crocodiles remain within the mother's territory, where survival rates are higher. With lifespans that can extend for several decades, Nile crocodiles contribute to relative population stability across many river systems. The long-term presence of mature individuals helps maintain ecological structure, where the role of apex predator remains consistent across environmental cycles. During dry seasons, when water levels decrease and prey concentrates around remaining water sources, Nile crocodiles become especially effective. Limited water points become zones of concentrated interaction, where crocodile ambush strategies operate with maximum advantage and determine the outcome of many encounters. The presence of lions alters the entire savanna even when they are not fully visible. Signs of an apex predator, including lingering scent and distant sounds, are sufficient to cause other species to adjust behavior. Within this context, the savanna becomes more cautious as every movement must account for potential risk. African lions live within stable pride structures, which is a rare trait among felines and provides clear advantages in open environments. Each pride occupies a defined territory where individuals cooperate to defend living space and food access from intrusion by other prides. Territorial control allows the pride to maintain access to prey and reduces prolonged conflict. Within this pride structure, lionesses play the central role in hunting activity. They form the primary force that approaches, surrounds and brings down prey through coordinated action. Male lions focus on defending territory and the pride while maintaining stability against external threats, including competing males from other prides. Lion hunting strategy relies on precise role assignment and timing. Individuals use terrain, low vegetation and wind direction to approach prey at the closest possible distance without detection. This coordination allows lions to subdue prey much larger than the capability of a single individual while reducing time and energy expenditure. However, lion hunting success rates are not consistently high. Many hunts end without capture, especially under high temperatures and across the wide open savanna. This demonstrates that even apex predators face energy limits and risk where each failed chase imposes a measurable cost on pride endurance. Outside of hunting, lions spend most daylight hours resting. These periods support energy recovery and play an important role in skill transmission to younger generations. Lion cubs observe adult behavior, including prey approach and responses to danger, and gradually develop skills required for independent survival. At South Luangwa, lion populations face increasing pressure from habitat reduction and human conflict. Conservation programs focus on maintaining continuous territories and reducing conflict to ensure lions retain sufficient space to perform natural survival behaviors. As apex predators, African lions help regulate prey populations and maintain balance within the savanna ecosystem. Their presence directly influences behavior, distribution, and activity patterns of many other species and shapes the ecological structure of the entire region. Chacma baboons live in complex primate societies where individual survival is closely linked to group behavior. Unlike solitary species, baboons depend on extensive social networks in which each action affects overall stability and safety of the troop. Hierarchy within the troop is clearly established, especially among adult males. Social rank determines access to food, mating opportunities, and level of protection during dangerous situations. Females play a central role in maintaining long-term cohesion through stable relationships and by passing survival knowledge to younger individuals. Communication forms the foundation that allows this social structure to function effectively. Chacma baboons use vocal sounds, facial expressions, and body language to convey information about social status, food, location, and presence of threats. These signals enable rapid and coordinated group responses, even when individuals are spread across wide areas of the savanna. As seasons change, baboon troops move in response to food and water availability. These movements follow organized patterns, with experienced individuals leading, while weaker members remain protected near the center. This formation reduces risk when crossing open areas or zones with higher exposure to predators. Dietary flexibility is a key factor supporting baboon survival in changing environments. They exploit fruits, seeds, roots, insects, and other food sources as conditions shift. This flexibility reduces reliance on a single resource and allows rapid adaptation to seasonal variation. When facing threats, baboons rely on collective defense. Adult individuals, especially males, may assemble to form protective barriers, while juveniles and weaker members remain behind. Group response increases deterrence and reduces likelihood of direct attack. African buffaloes live in large herds, where population size and strong cohesion form the foundation of survival strategy. Each herd includes individuals of different age groups, from calves to fully grown adults, and moves together across the savanna to access seasonal water sources and grazing areas. This collective movement reduces the risk of isolation and maintains the ability of the herd to respond to potential threats in open environments. Key herd decisions do not depend on a single individual. Buffaloes demonstrate consensus-based decision-making as individuals express movement preference through behavior, posture, and spatial position within the herd. The final direction reflects the options supported by the majority, which reduces overall risk and limits decisions that could increase danger or cause fragmentation. When facing predators, African buffaloes rely primarily on collective defense. Adult individuals rapidly form a defensive ring that places calves and weaker members at the center of the formation. This arrangement reduces direct access for predators and forces attackers to confront multiple strong individuals at the same time, which increases the cost of any attack attempt. In some situations, buffaloes extend beyond defense and initiate counterattack. Coordinated movement by multiple individuals, combined with large body mass and short burst speed, can force predators to retreat. Even apex predators on the savanna must carefully assess risk before continuing engagement because injury risk during these encounters remains high. This high level of danger and unpredictability has led African buffaloes to receive the name Black Death. This designation reflects the reality that approaching or hunting buffaloes carries significant risk for any predator, especially when herd cohesion and collective response remains strong. Within the savanna ecosystem, African buffaloes serve an important ecological role. Their movement and grazing activity directly influence vegetation structure by creating areas of short grass interspersed with taller grass zones. The presence of large herds also shapes predator behavior, hunting strategy, and spatial distribution, which helps maintain dynamic balance within the ecosystem. Within the same savanna landscape of South Luangwa, each observed species demonstrates a distinct survival strategy that reflects adaptation to environmental pressure and interaction with other species. Elephants shape the landscape through body size, mass, and migratory memory accumulated across generations. Hippopotamuses control the boundary between water and land through a semi-aquatic lifestyle. Crocodiles rely on absolute underwater ambush strategy. Lions maintain apex predator position through coordinated strength and pride structure. Chacma baboons persist through collective intelligence and complex social organization. Vervet monkeys maintain safety through early detection and accurate signal transmission. African buffaloes protect themselves through strength of numbers and herd cohesion. These strategies do not converge into a single survival model. Each species succeeds in a way that matches its ecological position within the savanna. As seasonal conditions change, water availability, food distribution and predation pressure also shift. Under these conditions, advantages held by one species may decline while strategies of another become more effective. This continuous adjustment creates a dynamic balance where no species maintains absolute dominance in all situations. The savanna operates through this diversity of behavior. No species exists in isolation from surrounding ecological relationships, and no strategy functions independently. Differences in adaptation, response and interaction with the environment have maintained the relative stability of the South Luangwa ecosystem over long periods, despite ongoing climate and resource fluctuation. Vervet Island Passage is recognized as a major marine biodiversity corridor in the Philippines, where ocean currents continuously transport nutrients and larvae between multiple marine regions. This constant movement creates a broad connective network that enables exchange of genetic material and energy among populations. As a result, the region maintains high species density and complex biological interaction rarely observed in tropical marine ecosystems. The foundation of the marine ecosystem within Vervet Island Passage consists of densely developed coral reefs, the three-dimensional coral structure forms multi-layered living space that provide shelter, breeding grounds, and feeding areas for numerous marine species. These reefs also stabilize the seafloor and regulate localized currents, which allows biological processes to occur continuously and efficiently. Giant clams function as important biological filtration components within reef systems. By filtering large volumes of seawater to obtain food, they help maintain water clarity. This filtration directly supports corals and light-dependent organisms and strengthens overall reef ecosystem resilience. Ocean sunfish appear seasonally in open waters of this marine corridor. Their large body size and wide-ranging movement place them within offshore ecological networks where energy transfers across multiple trophic levels. The presence of ocean sunfish reflects connectivity between coastal waters and the open ocean. Whale sharks use Verde Island Passage as a significant feeding route. They move with ocean currents and exploit seasonal concentrations of plankton. This behavior allows whale sharks to maintain required energy while traveling across multiple marine areas. It also links plankton populations with large filter-feeding species. Dugongs maintain close association with nearshore seagrass meadows where they spend most of their time feeding. Grazing activity not only meets individual nutritional needs, but also shapes seagrass structure and distribution. This process directly affects underwater vegetation, regeneration, and nearshore environmental stability. Each ecosystem on the planet operates according to its own logic, shaped by landform, climate, and relationships among species within that space. These principles cannot be applied uniformly, because each environment imposes different conditions and limits on the persistence of life. In the natural world, survival is not a display of strength or absolute dominance. It is a continuous process of adaptation to environmental pressure, where success is measured by long-term persistence and balance rather than brief, dramatic moments.